Building a modern stadium is already a huge engineering challenge, but constructing one on top of a swamp filled with buried garbage is far more difficult. In Launceston, Australia, engineers are tackling this problem with the $130 million redevelopment of UTAS Stadium. Beneath the field lies soft swamp soil, buried waste from the 1800s, and groundwater sitting just below the surface. The project is more than a simple upgrade. Engineers must solve a major construction challenge: how to anchor a massive stadium into ground that constantly shifts, sinks, and fills with water. From swamp to sports ground. Before becoming one of Tasmania's most important sports venues, the land beneath UTAS Stadium was known as the Eastern Swamp. In the early days of Launceston, the area was a wet and muddy landscape filled with reeds and vegetation, making it unsuitable for construction or farming. During the 1800s, city officials began using the swamp as a dumping ground for rubbish and soil in an attempt to reclaim the land. By 1873, the filled-in area had become the Launceston Showgrounds, hosting community events and agricultural shows. The local council took control of the site in 1881, and cricket matches began there in 1886. However, the swamp beneath the ground never fully disappeared, and the field often became waterlogged during winter. In 1901, the venue was renamed York Park, and after a stadium design competition in 1919, construction began. The stadium officially opened in 1921 and soon became the main football venue for northern Tasmania. Despite setbacks like the devastating flood of 1929, the community repeatedly rebuilt the ground, transforming what was once a swamp and rubbish dump into a major sports venue. The engineering nightmare beneath the grass. The biggest challenge at UTAS Stadium lies underground. The site sits on an old landfill where layers of decomposing waste, mud, and water create unstable soil that can shift or sink under heavy structures. Engineers also discovered that groundwater in some areas is only about 200 millimeters below the surface, meaning even small holes quickly fill with water. To keep the new stadium from sinking, builders use deep piling. Massive steel and concrete piles are driven about 20 meters into the ground, passing through soft mud and buried debris until they reach solid rock. These piles create a stable foundation strong enough to support the stadium's stands, roof, and lighting towers. Without this technique, building a modern stadium on such unstable ground would not be possible. Transforming the stands and seating. The redevelopment plan includes major upgrades to nearly every part of the stadium. One of the most significant projects is the construction of the new Center West stand. The old structure was demolished in September 2025 to make way for a modern replacement that will include corporate hospitality suites, television broadcast areas, and upgraded locker rooms for athletes. Across the field, the eastern stand is also being completely rebuilt. When finished, it will contain 3,629 new seats, dramatically improving the spectator experience. Engineers are also modifying the western stand by adding infill seating. This process fills previously empty spaces between sections, bringing fans closer to the action on the field. Accessibility has also been a major focus of the design. More than 50 new wheelchair-accessible spaces will be installed to ensure the stadium can accommodate fans of all abilities. Once construction is complete, UTAS Stadium will have a total capacity of approximately 17,600 spectators. A field designed to fight flooding. Because the original swamp conditions still influence the site, preventing flooding has been a central priority. Rather than building a perfectly flat field, engineers designed the oval with a subtle dome shape. The center of the playing surface is slightly higher than the edges, with a slope of about 0.5%. This gentle incline allows rainwater to flow toward the edges of the field, where drainage systems carry it away. Beneath the grass lies a carefully engineered structure designed to manage water efficiently. The top layer is a 250 millimeter thick sand layer known as the root zone. This material allows water to drain quickly while still supporting healthy grass growth. Below the sand sits a layer of gravel and a geogrid reinforcement system. The geogrid acts like a strong fabric, preventing the sand from sinking into the soft soil below. Together, these layers create a playing surface capable of handling heavy rainfall without turning into mud, stabilizing the ground. The unstable soil at the site required several engineering solutions. In some areas, the ground was so soft that heavy construction vehicles risked getting stuck in the mud. To fix this, engineers mixed lime and cement into the soil, a process that hardens the ground and creates a stable surface for equipment. Environmental safety was also important because the site once served as a railway area and landfill. Small traces of metals like copper and arsenic were found in the soil, so workers followed strict safety procedures during construction. Landscaping was carefully planned as well. A historic Dutch elm tree had to be removed, but its wood will be reused for stadium features, and 4 new trees will be planted to replace it. Advanced lighting and infrastructure. Modern stadiums rely on complex systems working behind the scenes. At UTAS Stadium, 5 massive lighting towers about 45 meters tall support powerful floodlights designed for television broadcasts and strong winds. Beneath the field is an extensive network of pipes and cables, including an irrigation system with 106 sprinklers and more than 2,500 meters of piping to keep the grass healthy. The drainage system can handle up to 100 millimeters of rain in just 1 hour, preventing flooding during heavy storms. A continuous lead ribbon board will also surround the field to display scores, replays, and advertisements during games. Construction while games continue. One of the most complicated aspects of the project is that construction is happening while the stadium continues to host events. To make this possible, the work is being carried out in carefully planned stages. During the 2026 season, the stadium's capacity will temporarily drop to around 9,000 spectators so that construction crews can safely build the new stands. Engineers are using building information modeling, a sophisticated digital planning tool, to visualize every component of the stadium before it is built. This technology helps prevent design conflicts and construction errors. Workers must also monitor vibrations from pile driving. Excessive vibrations could damage nearby buildings, so engineers continuously measure and adjust their equipment to keep the levels safe. A project for the future. Beyond sports, the redeveloped stadium is intended to become a major community hub. The new Center West stand will include function spaces that can host business events, conferences, and concerts throughout the year. Large windows and open interior spaces will create a welcoming atmosphere filled with natural light. The exterior architecture also reflects the local landscape. Precast concrete panels have been shaped to resemble Tasmania's natural rock formations, helping the building blend into its surroundings. Safety remains the top priority. Designers followed strict international guidelines known as the Green Guide to ensure safe crowd movement, adequate exits, and properly designed stairways. When the redevelopment is finished in October 2027, UTAS Stadium will be ready to host the new Tasmania Devils team starting in 2028. Who is paying for the project? The total cost of the redevelopment is estimated at $130 million. Funding is being shared equally between the Tasmanian state government and the Australian federal government, each contributing $65 million. Most of the construction work is being carried out by a local company called Fairbrother, helping generate jobs and economic activity in the region. However, the project has not been without controversy. Some critics argue that public money would be better spent on housing or healthcare. Others worry that construction costs could increase due to the unpredictable nature of building on unstable ground. Despite these concerns, the redevelopment is progressing rapidly, turning a swamp into a landmark. What began as a wet swamp filled with rubbish has evolved into one of Tasmania's most important sports venues. Now, engineers are attempting to transform it once again, this time into a modern stadium capable of hosting professional football, concerts, and major events. The challenge is enormous. Beneath the grass lies unstable soil, buried waste, and groundwater waiting just below the surface. Yet through advanced engineering techniques, deep foundations, and innovative drainage systems, builders are slowly turning this difficult site into a world-class stadium. If everything stays on schedule, the transformation will be complete by 2027. And when the first major game kicks off in 2028, thousands of fans will fill the stands, likely unaware that beneath their feet lies one of the most complicated construction sites in modern stadium engineering. If you found this incredible engineering story fascinating, make sure to hit the like button and subscribe for more videos exploring the world's most ambitious and challenging construction projects.